Welcome everyone to the second webinar of the project about open calls and about UDENE tools. And we will show you our outputs and explain to you what we are expecting to do in the next few months and how you can apply on our open calls. For the first part, I'm going to give the floor to our coordinator, Türkiye, so you can represent the project and everything that goes through our project. Thank you.
Thank you, Maya. I will share my presentation and make a brief introduction to the project. Okay, so my name is Ali Tunçer. I'm the coordinator of the project on behalf of We Global. We Global has offices across Europe, mostly in Balkans, but also Italy, Netherlands, and We Global Italy is the coordinator for this project. And now this is for the first open call, already open, accepting submissions. And the context of this call is educational. So we titled as Geodata Science Education, but it can be geomatics education, it can be remote sensing for urbanization education, or any title you find suited. It's a generic term we have here, Geodata Science, but what we expect is some educational plan with a syllabus and lesson plans. Today we will cover the Tunisian use case for the project. It has 3 use cases. The one for Tunis is the focus today, but of course we will review the Turkish and Serbian cases as well. And before that, the tools we developed right after the overview of the open calls from Maya. Okay, so this is a research and innovation project. It means the outcome is a prototype. It's not a stable product for the market, but basically a research outcome. And it's open source. It's at GitHub. We will share the library with the winners to develop their ideas. In case of educational plans, maybe their use cases to be a context for the education. And it's awarded from the Copernicus International Partners Call. Now, Copernicus is a Earth observation satellite system developed and launched by European Union. They report it cost 20 billion euros. At the moment, half the missions are in the sky, middle Earth orbit satellites, 12 of them. Each mission has 2 or 3 satellites. So 6 missions have been executed, and they are satellites equipped with various sensors for Earth observation, infrared, hyperspectral, and their data are crafted into a number of services. You see a list of them here: climate change service, marine monitoring service, land monitoring service, and emergency management service. These services can be activated and used by all the member states, but also by international partner countries. And this call was dedicated for those partner countries. They include countries like Japan or Canada, but also African Union, Serbia, and so we have Tunis in our consortium representing the African Union. We have Serbia, we have also Turkey, and so our use cases are in these 3 countries because they are international partners of the Copernicus program. It's sponsored. The grant comes from EU SPA, who piggybacks the Horizon Europe platform, the funding and tenders portal, the project management utilities. This call was from 2023 work program. Project started 1st January 24, and it will finish end of this year. Now, a new service, right when the call was issued, is called Copernicus Data Space Ecosystem, which appends the data from these satellites with local data or other sorts of data like meteorological data or population data. Anybody can contribute to this ecosystem as long as they suit a number of standards like geotagging and time codes, and they are standardized so that the data can be aligned in various dimensions, but most important in terms of geolocation and time. Very briefly, EUSPA is similar to European Space Agency, but more focused on applications, downstream, upstream. Upstream applications like hard satellites, launch programs, satellite management, all that. And the downstream is like UDENE project, building applications using Copernicus system or the Galileo system. So USPA runs a number of grant programs in Horizon, as well as competition and support for small, medium-sized enterprises and new ideas. It's definitely an agency to follow.
Ali, I'm sorry, you muted yourself. Ali, I'm sorry, can you hear me? You're still muted. Let me try. Funny?
Okay, you hear me now?
Yeah. Yes, thank you.
Sorry for that. So the first objective is the main objective. It's the idea of the project, to find natural occurrences of urban development concepts using Earth observation datasets across time and place. So, and we need to do this fast. Obviously, we talk about global datasets, a lot of information, and we are seeking a specific bits there. So it's a challenge to search big data sets for specific information. That's why our solution involves a data cube, some structured data facility. This runs in Amazon Web Services, and it links to the Copernicus data space ecosystem, where we get the data, load to the cube, and search using causal effect models. So the idea is this urban development concept should affect an intended outcome causally. So if we can model this effect, then we can figure it in the global data set. That's the first objective. The second one, since this relies on models, the second objective is to make sure these models are causally reliable. That's why we do the sensitivity analysis. At the moment, we have models for our 3 use cases. So those are subject to sensitive analysis. But the analysis tools are generic. They can be used to check new models. In this open call, new models are not indicated, but if you introduce, you can also subject them to sensitive analysis. All right. And the third objective is to promote the international partners. In our case, Tunis, Serbia, and Turkey. to build synergies between them and the European downstream sector applications and services with the relation. Okay. So I mentioned these use cases, but concretely, the Serbian case involves air pollution decreased with the new bridges. So here the urban development concept is new bridges, and the intended outcome is decreasing air pollution. In the Tunis case, it's a park system, which is intended for decreasing the heat load. And in Turkish case, it's high-rise buildings, using high-rise buildings for residential areas. And the intention is not to change the economic laws in case of earthquake. Of course, an earthquake scenario. So it fits a Richter scale degree of the earthquake, its various parameters, and then we try to calculate the economic loss due to this kind of urban settlement. And therefore, the data sets we use are related to these challenges. For instance, in Turkish case, we use the global human settlement layer, the urban atlas. But for Tunis case, we use Copernicus DEM, the elevation information, and land cover maps, land change detection maps, vegetation monitoring, vegetation indexes. And for the Serbian case, Sentinel is the Copernicus satellite. We use its pollutant emission sensors, or the services which calculate these emissions from the sensors, sensor information. And atmospheric quantities are from air applied datasets. Okay, so how do we detect the natural occurrences, which is called natural experiment? First step is to build the causal model. So we have an idea, and we need to set an intended outcome. Also, the variables that can characterize this intended outcome, that are related to this outcome. The outcome can be energy consumption, mobility measures, like traffic congestion, number of congestions per day, efficient water use, and the input variables obviously has to exist among the available data sets, Copernicus data space ecosystem. So they can be social economical data, climate data, land use data, and such. And as models, we can use which connect the model connects these variables, input variables to get an outcome. So it can be a multivariate model. It can be a regression model. It can be an agent-based model. We discover in the literature the state of the art for modeling such phenomena, and we improve it and use it in our system. Of course, after doing the sensitivity analysis, so making sure it's the best model. The second step is to sort the input variables in 2 dimensions. First, whether they characterize the area of interest or they characterize the intended income. And the second dimension is if they would change with the urban development concept or not. So that gives us a 4 sets of input variables. And we use this division in the step 3. First, we filter out the relevant places to search based on the characteristics of the area of interest. So if we are concerned with an area of interest in Tunis, obviously we don't need to search Antarctica. So we need similar places to the Tunis in terms of characteristics such as land cover, land use, population density, or climate. It depends on the context of the idea. of course, but this first step is to limit the search space. That's to save time. And the second step, okay, now here, the idea is to find outliers, in terms of the intended outcome. Obviously, if we have a data set which directly measures the intended outcome, then we can seek the outliers there. But if there is no such data set, obviously we need to use a proxy for this intended outcome, and that proxy is the variables as processed in a model that would change with the idea. So, as an example, like in the case of a park system in a city, this would affect the temperature-related heat load, but it wouldn't affect the anthropogenic heat load. Heat generated in industrial buildings or residential buildings, that wouldn't change with this park, huh? But the land temperature and air temperature may change. So, in summary, in this third step, we find similar places to Tunis, but with a much lower air and surface temperature. And this abnormally low temperature must be due to an intervention. That's our hypothesis. And this intervention may be a park system. So we present those places to the user, and the user observes if it's a park system that causes this low temperature, or maybe another solution, like I don't know, lake, an artificial lake in the city, or some other cooling idea. So that we call the inverse use case. That's another use case for UDENE to help urban developers come up with original or ideas that work. So the forward use case is to provide them evidence that their idea would work, but the inverse is to provide them alternative ideas. That's it. And so this logic runs in the exploration tool. And the second tool of our system is called the matchmaking tool. This one just uses the text written by the user to describe his or her idea of urban development. We analyze that text and come up with such important keywords, let's say, and then we search the Earth observation mole, which is a database of products and services from Europe that uses mostly the Copernicus system, but also other Earth observation technologies. So we search that database for products and services using those keywords and display the top two under the page with a link to the service, so the user can go there and maybe choose to contact this service and work with the service provider to implement his or her idea. So that's my presentation. That's briefly the UDENE project, the Copernicus system, and USPA. Again, somehow Copernicus and USPA is a bit underutilized in these international partner countries. So UDENE open calls are intended to increase that, to change that trend. So I thank all of you for your interest and effort in participating in our call. Thank you.
Thank you, Ali. Next topic is going to be the overview of our open calls. I'm going to go through both open calls because they're both active now, but mostly I'm going to try to familiarize you with the process and with the tools that you already have on our websites and our channel. Before I proceed, I would like to say to our participants that you have a Q&A section where you can ask any questions that you would like an answer to regarding any of these presentations. And we will make some of the questions we will answer live, but mostly the questions are going to be gathered and answered and updated on our website. We will show you where. And then if you have any questions outside of the webinar, when you go through the documents and you decide to apply and you have any other questions, you can always send them to us and we will respond via the same model. So you will have a kind of a database of asked questions and answered questions where you can see, and everybody who wants to apply and applies can see all the questions and answers that we produce. So now I will continue with my presentation about UDENE Open Calls. I think I hope you see my screen. So both open calls are live now, and we predicted that we are going to use them to have a process of open calls through July and August. So this is our timeline. You can see on the right side of the screen, you can see the timeline, let's say short timeline, which is kind of overlook of the timeline, but on the left side you can see it in detail. So open call 1 was opened on June 18th. Then it's going to, the deadline for submission of the open call 1, the one that Ali was talking about the development of the courses, it's going to end August 16th with the timeline of 9 p.m. Brussels time. This is the last time when you can send your application. Then after that, we will have the process of evaluation and winner selection, which we're going to talk about a little bit after the few introductory slides. Then in September, by the end of September, we're going to finish our contracting, and in October and November, we plan to have you develop your projects. And for Open Call 2, it's a similar timeline, so opened on July 1st, ending on 29th of August. And timeline for the other evaluation and contracting is the same as the first one. So by the end of September, we would like to have contracting finished, and then you can develop your projects in October and November. With the last report filed sent to us in the middle of September. So if something changes with these dates, it's going to be announced, and all the participants of the open call are going to be informed. So mostly you can find all of the information via UDENE website, UDENE open call web page, where you already have in the end of the page, you already have application form. You can go through it. We're going to go through it today. And you have your credentials to see how the form looks like. And when you decide to apply, you can apply with these credentials for both open calls. For open call 1, which is UDENE tools integration into your data science application. Any open call number 2, UDENE tools for global business solutions that accelerate Copernicus adoption. These are the links for the webinar. So we have one more webinar that is going to be in the scope of call number 1 on 28th of July at 1 o'clock. And then open call for open call 2, we provide info sessions that are going to be all in August. So 11th, 13th, and 15th August at 1 p.m. Registration links are going to be shortly publicized on our website. So as I already mentioned, all the questions that we receive through webinars here in the question and answer section, or the questions that we receive through our website, technical support email, we will provide in the frequently asked questions database, kind of a document with all the questions and answers provided. So this is the part of this web page that is on UDENE website, where you can download firstly Annex 1, which is open call fichier, which has all of the information that I'm talking about today, but also much more information that can orient you about call number 1 and call number 2, what is possible, what is the idea, what we ask of you, and what is the task at hand. Then my suggestion is to go and look over our tutorials and webinars that are going to be recorded and published on our UDENE YouTube channel, and then also use Annex 2, which is a guide for applicants, which is actually the tool guide. So it explains while you watch the tutorial, it can provide to you much more information about tools that you can use if you win the open calls. So these first two documents, Annex 1 and Annex 2, are my first suggestion for you to go over. And then afterwards, we have the documents that you're going to have to provide when you choose to apply for open calls with an open calls. So declaration of honor, ethics, intellectual property and security declaration, and if you are a SME, financial stability for SMEs. And here you have a model of sub-agreement, a sub-grantee agreement, which is going to be just for you to overview how the contract is going to look like, which is also going to have to change a little bit depending on who is the winner and from which country is the winner, etc., and what type of organization are you. So after that, on this web page, you also have information about technical support within the funding and technologies that we use, but also on this page and on UDENE YouTube channel, you can see, as I already said, videos and tutorials, PPT presentations about all the tools that we are providing and about the open calls process. In the end of the page, you see where is the application forms and when the submission deadline is, where you can submit your proposals. This is how the application form looks like. I'm going to go through it a little bit, but you can also, with the credentials you have, you can go over it too, but here it is for you to see. So this is the first page, and then we have two stages explained to you. The first page or first stage is eligibility and feasibility, where you have to provide what type of applicant are you, what is the target country, Serbia, Turkey, or Tunisia, what is the contact person, entity, phone number, email address, or other contact person that you may have from your organization. And then on the second page, the stage 2 is what will you do? So each section has 4,000 characters possibility, which amounts that the full application form is going to be about 4 pages, A4 paper for you to provide for us. So you will need to provide to us concept and contemporaneity, impact, relevant expertise, and of course, you will have to submit a work plan with task descriptions. What will you do to provide us with the output that we need? And in the end, the last page of the form is actually the page where you're going to upload the signed declaration of honor. You will download it from our website, fill it out, and then upload it in this form. The same thing for ethics and intellectual property and security declaration. And in the end, for small and medium enterprises, SME declaration of stability, if necessary, is going to be uploaded here too. So open call, general proposition. So we're going to have 2 open calls. We already have 2 open calls. 6 open calls are going to be delivered per winner, per open call, and 2 winners per country. So we have 3 countries, Turkey, Serbia, and Tunisia, and we're going to have 6 winners per open call, which amounts to 12 winners total. We are the funding. We have a funds of 120,000 euros, which amounts to 10,000 euros per winner. Final report delivery that we expect from you is going to be 15th of December. So all the work is going to be done in October, November. It's going to have to be feasible within 2 months, and it's going to have to be in the UDENE tools functionality scope. And in the end, we are expecting for you to provide to us final report by December 15th. Only single applicants shall be eligible, and application, as I already said, is going to be up to 4 pages. It's going to be in MS forms, as I showed you already. So the first goal, as Ali already said, it's UDENE tools integration in geodata science and education. So the purpose of the call, this all information is in the open call fichier. The Annex 1, I showed you where it is. The purpose of this call is to expand the skilled practitioners of geoscience, geodata science in Copernicus international partner countries by using UDENE open source tools. So what are we expecting to be the outcomes? It's a curriculum design for geodata science and applied discipline, education models, of course, content or course content, and demonstrative case studies suitable for the intended skill levels, showcasing the use of the UDENE tools. What are the outcomes? Learning outcomes, accredited skill and competence in geodata science, curriculum to up to 3 ECTS credits, competence development assignment involving practitioning with the UDENE tools, and demonstrative case studies, at least 3 covering preferably urban development challenges that could be addressed by Copernicus EU solutions and UDENE tools. The second one is UDENE tools for global business solutions that accelerate Copernicus adoption. What is the purpose? To stimulate international business collaboration by international business collaboration by integrating UDENE tools into market-driven solutions. What are the expected outcomes? Market-ready business-oriented solutions, feasibility studies, and business cases. And the output that we expect is detailed business cases, partnership documentation, pilot projects, and market entry and sustainability plan. All of this information are, as I said, in our document open call fichier. A little bit about our application and evaluation process, which is going to be very important for our applicants, is when you apply to the open call. First, we check eligibility. Then our external evaluators are going to look over your application. So if you're eligible, you're going to get evaluated. Your application is going to be evaluated. If you're not eligible, then you're going to get something that we call process information documents. Process information documents are rejection letter, acceptance letter, proposal evaluation sheet, and/or consensus evaluation report. If you're not eligible, in this case, you will get the rejection letter and explanation why you received the rejection letter. If you're eligible, your application will be evaluated from our external evaluators, and if they find that it's a good application, they will going to score it, and in this case, you will receive the results of the application. If you do not pass the scoring, you will get the rejection letter and the explanation why your application is unsuitable. In the case that 2 or more applications have the same scoring, we have the consensus evaluation and ranking, where we will have an interview with applicants and the whole consortium and our external evaluators to see and to provide more information about the application, so we can decide on the scoring and to make these applications differentiate. In the end, the results are going to be announced, and we proceed to contracting and winners promotion. In the end, you're getting your acceptance letter and proposal evaluation sheet and consensus evaluation sheet if necessary. Our evaluation process is two-stage process. So eligible organizations or individuals should be established in Turkey, Serbia, or Tunisia. Stage 1 is the screening procedure for eligibility and feasibility check. If what you are proposing is feasible, and if you are eligible as a applicant, these are the organizations and individuals we are targeting. So SMEs, startups, NGOs, local authorities, associations, education and training organizations, research institutions, and individuals or team of individuals based in one of the target countries and as defined in Horizon Europe rules for participation. And the stage 2, the quality assessment procedure, concept and contemporarity, impact, and applicant expertise are going to be assessed by our external evaluators who are going to score these 3 concepts through the defined subgroups. I'm going to finish, don't be scared, with this big slide, which I'm going to share with you all of these links, which can add you then to the, within a project, we're going to lead you to the open call webpage, to all the annexes where they are, and our YouTube page where you can find the video tutorials and everything possible. Of course, our LinkedIn and Facebook page. Why? It's not just to follow us and to gain followers, but this is going to be really important for applicants because all the information are also going to be shared through LinkedIn and Facebook and Instagram and all UDENE channels. These links I'm going to put in chat so you can go through them immediately or save them as you want. So thank you for your attention and to all the partners, and please, as I said, subscribe and follow us because all the information we're going to share through our within the website and through our channels. The next is going to be the is going to be the UDENE exploration and matchmaking tool demo session. So Murat or Hussein, you can take over.
Okay, thank you. Actually, we're gonna do both. So you're saying you can share the screen, I guess?
Is it visible?
Okay. So in order to use the exploration tool, first you need to go through the login privilege. And first you can, I mean, for the first time, you can register. When you click on the register button, it asks you about, I mean, your name, last name, standard stuff. So it's simple. So there's not much information required to register to the system. So once you register, you can enter your email or as your login, and then just the provided password, and it enters into the application. So the basically the main interface is simple. There are only 3 tabs: datasets, experiments, use cases. In the dataset tab, we have the global datasets and we have the institute datasets. For the global datasets, we have every available dataset, and you can, once you click on one of those, you can select different bands and like different, like let's say data on the specified regions. So you can download the data, you can export. So obviously this is dynamic, so it can be added, everything. You can upload a data set. So this is quite generic in that sense. And what the resolutions or requirements totally depend on, I mean, the data set itself. So there is no specific requirement for what you can load or what you need to show. So this is for showing, I mean, providing a general view of what sort of data is out there. For institute data sets, this is the data sets that are not available, I mean, in generic form. So this is something that's the, let's say, partners or like the people who want some specific, let's say, requirement from the usage can load. So these are not obviously the satellite data. This is so it's not available throughout everywhere. So the regions that these are defined needs to be, I mean, specified in the data set itself. But it shows what's out there. So obviously, again, like there can be multiple or more institute data sets that's available. So right now we put as the use case requirements. So, but it can be expanded, obviously. So since the use case representations will use these, you can check what's in there, and then obviously once you want to try a new use case or some new trial, you can upload it. So it's where it goes. So the experiments part now with these data sets, you can basically try an experiment to see the natural experiment where which part of world, or I mean, I would say wherever the areas of interest that are in the system matches what your expectations are. So there are two modes, automatic and manual modes. Basically, in manual mode, you select your inputs, you select what you want, and you select the model and everything. So you have the full control. So that means you somehow need to know what you are doing specifically in parts of the inputs, which inputs to select. So in that sense, this is like in quotes, like an expert, let's say, version. So you can, for example, here, which data set you will use, what basically inputs you will select, and what do you want as the outcome. You can add as many as you want, obviously, to the system, and then it'll find the proper places. So, I mean, we can try something in that sense, and then see what it comes. You can select a timeline, the time window, so it'll find the images from those specified time intervals. Also, you can define how close the values are through the perturbation, and you can also specify what's the how much, for example, the output will change from the outlier, let's say, specification. So these are all adjustable items. So obviously it takes a while depending on what you are trying to select. Okay, so okay, it found such places. Can you hear me? I think I lost the connection.
Yes,
Yeah.
we hear you.
Now we can hear you.
Okay, something happened, I don't know. So it'll look through similar zones, similar places, area of interest, because, well, obviously, it makes the query much faster and more efficient. So this is the manual part it found. So let's go for the automatic. This is much easier, and in that sense, this is a novice again in code usage. You just specify what you are trying to do, and then you run your experiment. Here you don't specify any inputs, any outputs. You just specify. You type the text you type your prompt, and it runs the experiment, and it decides which inputs are required for your query and what output you need. And obviously you again select your area of interest in a similar fashion. But this is obviously easier. But if you want specifics, obviously, for example, some other extra in that sense. Okay, did it find something? Yes, it found similar places. Obviously, you need to check how those look like and everything. So, depending on, again, like the default perturbation values or outlier sensitivities, the result can change. So it's you need to work on it to see which fits best to your case. So that's how the automatic, let's say, exploration part works. So obviously you need to. It's again your responsibility to type in like a correct prompt in that describing your idea area. But once you get used to how, how it works and what kind of just outcomes it provides, it's easier. This is easier to work on that. Okay, so I guess the last one is use cases. Here, already, let's say, worked on use cases in our, let's say, the 3 use cases that we are familiar with. There are more information you can export and download these ones. So here the idea is there are going to be more additional use cases in the step. So these are the main use cases that the model, the system provides. But obviously, when more usage is seen, there can be more use cases, and then people will see. If they find something similar that what they are looking for, they can directly download the use case here and then adapt to their needs. Or we can have more, like I said, trials in this part. So this is more like a showcase of what can be done. This, and it has the 3 use cases that are worked on in the project. So that's pretty much it, I guess. Okay, these are some, let's say, results and usage, let's say, statistics. So it shows, for example, at what time what's done, and then the experiments. You can get information about those, and then this provides the results. So that's about it for the exploration tool. We don't
Thank you, Murat.
Yeah. So
Thank you,
if there are any
Murat.
questions, yeah, you can
Again,
let us know.
Yeah, again, questions are question and answer section of this webinar. Next is a brief overview of use cases from Serbia and from Turkey. So Nicola or Seda, who is ready? Nicola?
I can read, yeah, I can share.
Okay,
Yes, please.
Seda.
Do you see it?
Yes.
Yes.
I can. Sorry for that. Maybe Nicola can start, or I can continue.
No, go ahead, please continue.
ahead.
If you're ready. If not,
Okay.
I can start as well.
Okay. Hello, everyone. I am Seda from the Next System. As a use case for Türkiye, we conducted our study titled Determination of High-Rise District Effect of Earthquake Preparedness within the scope of UDENE. The purpose of this use case scenario is to evaluate the structural damage and economic losses resulting from house construction in regions at risk of being exposed to earthquakes of magnitude greater than 7. As you can see in this slide, the use case revolving concept consists of the hazard map, human settlement, and risk map. From hazards to risk, the role of urban planning, structural durability, and modern design code is significant in mitigating seismic consequences. The hazard map shows the expected level of ground shaking at a specific location due to future potential earthquakes. Risk map shows that design codes and standards mainly drive the earthquake risk revealed by the models. Turkey is located on the orogenic seismic belt from the Himalayas to the Alps, and destructive earthquakes occur on this belt every 2 or 3 years on average. Since the country is located in a region with high seismic risk, working on this issue was very meaningful for us. The use case has specifically concentrated on Istanbul because Istanbul, the country's largest metropolis, is home to about 1/7 of Turkey's population, and half of its industrial potential lies in the west segment of active North Anatolian fault line. In our study, we would also like to talk about the importance of being prepared for an earthquake. Preparedness directly influences resilience and reveals your risk level. Therefore, disaster management and preparedness play a critical role in earthquakes. Knowing the seismotectonic characteristic of region and the location and structural status of the buildings increases the level of preparedness, which directly affects the loss reduction capacity. In this context, the possible effects of high-rise buildings were examined in detail in the study. In our scenario-based earthquake study, our implementation methodology is divided into 3 as hazard assessment, loss assessment, and urban development assessment. In the seismic hazard model, an earthquake scenario was created using the Bohr and Atkinson model. In the building damage assessment conducted within the scope of loss assessment, the Risk European Union taxonomy is used in the building database, and the urban geometry analysis, building layout, and street width to height ratios are specially analyzed to evaluate secondary risk. Considering the high density and irregular configuration of high-rise buildings, the Fikirtepe was selected for detailed analysis in the use case study. You can see the change in land use of the area of interest towards the construction over time in the satellite images listed from top to bottom on the right for the years. On this page, you can view the outputs from our use case study, including examples from the Marmara region and the Fikirtepe area. For the Marmara region, we can say that older buildings have higher damage rates, especially at D3 and D4 levels. This is likely due to inadequate structural design for seismic resistance and poor constructability. You can see the Fikirtepe study results on the right. Post-1980 RC buildings show significantly lower damages due to better design codes, but the high-rise factor might still pose latent risk, especially if non-ductile detailing or some irregular story effects exist. In summary, the urban development concept of Turkey's use case experiment focused on the high-rise district effect on earthquake preparedness. As input, magnitude, earthquake center, focal depth, fault data, shear wave velocity, and buildings information was utilized. And as output, intensity distribution graphics, building damage, and economic loss information was generated. Thank you for listening.
Thank you said that, Nicola, you can continue.
Thank you very much, Maya. Please let me know if you see my screen.
Yes.
Thanks. So, hello everyone. My name is Nikola Brenovic, and I will today talk about the Serbia use case, which was conducted within the UDENE project. So I come from Biosense, which is a research and development institute in northern Serbia. We are delivering IT solutions and innovations in the fields of agriculture, biosystems, and sustainable development. Our use case focuses on analyzing the impact of changes in transportation infrastructure to the air pollution. So in particular, we observed the city of Novi Sad and two sub-cases, where first one is building a southern bypass around the city to divert the heavy traffic, which includes building two new bridges. And the second sub-case is actually converting a heavy traffic section into a pedestrian zone in order to preserve the historical core of Novi Sad. And both changes are expected to have a significant impact on the transportation flows and consequently on the emissions. So to do this, we actually gathered, integrated, and used various heterogeneous data sets about the traffic network, traffic itself, pollutant emissions, both coming from in-situ measurements and Copernicus data sets, as well as microcensus data, actually the sample of microcensus data in Novi Sad and in-situ traffic measurements. What could be considered to be an step forward compared to this current state of the art is actually utilizing the traffic potential data originating by space syntax analysis conducted by Professor Marina Carevic-Tomic from the Faculty of Technical Sciences here in Novi Sad. So this data we wanted to see and to show if this data can be actually used instead of the in situ meter traffic data, which often does not exist in the urban areas. So to model this impact, the mentioned impact, we took both microscopic approach based on regression models and microscopic approach based on the agent-based models. Regarding the former, we experimented with several different Bayes regression models, such as linear regression models, multivariate polynomial regression, etc., as well as decision trees and random forests. While the last one, so the random forest regressor, showed to be the most efficient, had actually the best performance metrics, various performance metrics. Also, we experimented with different aggregations of data, which we had, such as daily, weekly, monthly, and so forth. And the daily aggregations at the end performed the best and gave us the best regression models for emissions estimations. Of course, we also did both local and global sensitivity analysis in order to see which features actually have the most significant contribution to our modeling, and for the purpose actually to create the models which are best utilized, so to have the least requirements regarding the data. On the microscopic level, we use the agent-based modeling where we actually represent the behavior of each participant within the city. So each person driving a car, driving a bicycle, or taking a public transport is represented separately and distinctively. With that, we can actually go into very fine granularity regarding building those precipitation models, and from there deriving the emission estimations. So, however, this very granular models and very sophisticated models are burdened with having not enough data to actually do this. And for that reason, we implemented new algorithms for household and population generation, actually extrapolation based on a rather small sample gathered within a city. We are able to, with quite high precision, generate the larger population representing the entire city. And of course, going into further details, creating the activity plans for each of those participants in the traffic. So we need to know when they are using transport system, in which way they're using transport system, which paths they are taking, and so forth. All this is taken into account in order to calculate the final emission estimations. So luckily, well, not luckily, but basically after a lot of hard work, we managed to come to this. So this is the sample of our agents, which are actually using the traffic system within the Novi Sad, and basically the colors of those agents represent the intention of their traveling, such as going to work, going to some leisure activities, education, coming back home, and so forth. So this was just in brief overview of the Novi Sad use case. For any further questions or information, please contact UDENE website or social networks or us directly. Thank you very much for your attention.
Thank you, Nicola. And if you want to see highlighted and a longer presentation about Serbian use case, you can visit our YouTube channel. It's going to be posted to yesterday's webinar. And for Turkey, thank you, Seda, again for the short presentation, but the Turkey will be spotlighted on 28th of July. Now, please, I call our Tunisia partners to give a detailed overview of their use case. Mohammed?
Hello, everyone. So
Okay.
I will start presenting the theoretical introduction. Do you see my screen?
Yes, everything is okay. You can go on.
Great. I am Sirin, data engineer in the Tunisian Space Association for the UDENE project. I will present to you the theoretical introduction of the Tunisian use case, which is the effect of a linked park system on heat load. So today's outline, we will start with an introduction, definitions and objectives of the use case. We present the study area, which is in Tunisia, the input predictors and outcome variables, the methodology, and some sample results that you will see in the exploration tool. For the use case introduction, our use case is the effect of a linked park system on heat load. So this is the main urban development idea, which revolves the creation and enhancement of a linked urban park system to mitigate urban heat island. So the urban heat island is the difference of temperature between the rural part of the city and the city center, and generally it's higher in the city center due to the positive correlation between temperature values and built-up areas, but lower in the rural areas due to the negative correlation between temperature and green infrastructure. So greening the cities is a climate change adaptation procedure which is involved in our urban development idea. That is the strategic design and expansion of green spaces, parks, and urban forests. But we are not just focusing on greening the city, but using the strategic approach while implementing these green spaces, which is called the linked park system, that includes connected different types of urban green spaces, such as green belts, green roofs, backyards, etc., to support freshness corridors. Our study area is Tunis, Tunisia, which is the capital of Tunisia, in the northern part of Tunisia, bordering the Mediterranean Sea. So it's a coastal zone. Our chosen area of interest is highlighted in the red rectangle with the following coordinates, and it is known as the Greater Tunis and includes the following municipalities: Tunis, Ariana, Manouba, and Benarous. Some geographic characteristics of our study area, such as the surface, which is 256 hectares. The population is about 2.6 million inhabitants. It is highly urbanized with dense residential, commercial, industrial, and institutional areas. The region presents diverse land-use, land-cover classes, including wetlands, urban green spaces, lakes, built-up areas, and the airport. Our use case or our study focused on the seasonal change in 2023. So our input predictors are the global Earth observation datasets and products, and we used some in-situ datasets that are exclusive to Tunisia. Then we developed a surface urban heat island prediction model to produce our outcome variables, which are the surface urban heat island maps. We also did some surface urban heat island simulation that I will show you later. Our input predictors are mainly Earth observation datasets, whether they are global or in situ. We used diverse data sources, such as the data cube Digital Earth Africa, to calculate the spectral indices from annual geocomposites of analysis-ready data, such as the Landsat or the Sentinel. We also used the cloud computing platform of the Google Earth Engine to produce urban green spaces maps from Sentinel to images with pixel-based classification. We used the global human settlement layer from Copernicus, the land cover from the European Space Agency product, and the local climate zones from UDENE platform. Here are some sample data that you will find in the exploration in the UDENE data cube. For example, here's the seasonal variation of land surface temperature. As you can see, in the winter we have lower temperature values, while in summer we have the higher temperature values. We have the local climate zones from UDENE and seasonal variation of the urban green spaces. To the processing part, the model for the surface urban heat island prediction. We use the random forest regressor and the formula land surface temperature in a certain pixel minus the land surface temperature in dense forest to have the surface urban heat island. We privileged the random forest regressor after comparing it with the other machine learning models. In fact, the random forest is an ensemble learning method with the bagging type that operates by constructing multiple decision trees, as you can see in the figure here, during training time and outputting the mean prediction of the individual trees. Next thing, I will show you the outcome variables, which are the surface urban heat island real map that we calculated with the formula that I've just shown, and the surface urban heat island simulation based on greening scenarios. So here, for example, see the seasonal variation of the surface urban heat island. And as you can see in the summer, so it's in July, we have the highest heat load spots. Here we did the simulation with the original urban heat island in spring, and here you can see a simulation while we increased pixels of urban green spaces, and as you can see, we have much less hotspots in the study area, which proves the hypothesis of negative correlation between urban green spaces and temperature values. Thank you for your attention.
Thank you, Céline. I'm sharing my screen for the demo. Could you see my screen, please?
Yes.
Perfect. So, as presented, Céline, the Tunisia use case, and I already logged in. Here in the experiment tab, we will run the Tunisia use case. In this search box, you can write the city or the county. So we will run the experiment on the Sfax city. And we have two options as previously presented, the manual and the automatic. For the manual, you can describe your idea. For example, in our case is to build a linked park system to reduce the urban heat island in Sfax city in Tunisia. You can select your data sets, for example, the Sentinel-2 data, or you can select automatically the indices, for example, here the NDVI, and you will select, or you have the ability to select the outcomes. In our use case, we will select the urban heat island. In terms of inputs, here we can select the needed inputs to be run in the model, and the start and the end date, and of course the model, the outlier, and the perturbation. Or you can just write your describe in the describing idea box. Just you can select the start and the end date, and of course you have to select the exact study area. So, and then we can run the experiment. Usually it takes a few seconds to 1 minute to be ready. We can just wait to see the results. Okay, here we have the original zone with the red pin, and the blue one is the similar zones. If we can just see the results, for example, for this area, this is the similar zones. That means with similar inputs and different outcomes. Here we have similar environmental condition, but with reduced urban heat island. The urban developer or the user can see around to explain and to find why this is reduced urban heat island. For example, here we can see a park, and that could explain the reduced urban heat island. For this area as well, we can see some green areas, and I think this is a park as well. Here it's an open green area. I think it's an old airport. This helps to reduce the urban heat island. So yeah, and you can download, as previously presented, the use case. Here, the use case where you can find the location, the date, the topic, the description of the idea, as well all the parameters that we selected. Here, the concept is the linked park system, the used datasets, the country. The outcome is the urban heat island, and the used predictors or inputs. We have the NDVI, NDBI, NDWI, the soil index, the vegetation index, and here the results, what is already presented by my colleague Céline. That's all from my side. Thank you.
Thank you, Mohammed. So this is the last presentation that we prepared for you. We are a little bit over at the agenda as usual, but we still have time for questions. If somebody, as I already said, but let me say it again, if you have questions, you can ask them in the Q&A section. If you don't have questions now, but you will have questions later when you start to prepare your application or just about the process and everything. We have the support for you prepared on the, you can contact us through webpage, website, and you can ask anything that you need from us to help you organize the application. So because we don't have any questions today in the Q&A section, I will leave you to a few minutes if you have any to post them. Of course, anybody is welcome to ask a question.
How about me asking a question again?
Oh, as always, it's okay.
Okay, so I was telling that African Union is the Copernicus International Partner, and we have Tunis representing African Union. What if I am from, I don't know, Morocco, and I'm interested in Earth observation, and I see this opportunity? Can I apply?
I'm sorry?
Can I apply for our open call? You know, if say I'm from Morocco, obviously African country, a member of African Union, which African Union is the Copernicus International Partner. So am I entitled to enter this open call?
Well, as the Serbia and Turkey and Tunisia are our target countries, you can maybe be a partner in as an individual team if you're from Morocco. If you have the ability to participate in application. But as we stated, the international partner countries, Serbia, Turkey, and Tunisia are target countries for these calls. I think.
Well, in my opinion, in case there are calls, because we mentioned Tunis specifically,
Yeah.
we are not, let's say, obliged to, because of our declaration for Tunis, we are not obliged to accept a proposal from Morocco if it fulfills every other criteria. But since Morocco is a member of African Union, and African Union is the Copernicus International Partner, it then depends on Tunis if they accept to support Morocco. I know Tunisia has relations to many other African countries, so if Tunis finds it suitable, of course, also depends how many quality applications are there from Tunis.
Exactly.
So we could be flexible there.
Depends also on the number of applications and how much fund do we have, and that's it. Yeah, exactly. Okay, we still didn't receive any questions in the chat, so I'm going to officially conclude this webinar and tell you everyone thank you for your attention and for participating. Thank you every presenter for presenting and showing your work.
Thanks everyone. See you later.
And also to say that the next webinar is designed for Turkey, and we can see each other then on 28th of July. Thank you, everyone.
Bye.
Bye-bye.